17C. All right, I'm on page 296. Number 1, 100 draws will be made at random with replacement from the box 112224. And we are going to make 100 draws out of this box. So A says the smallest the sum can be is 100. The largest it could be is 400. Letter B, the sum of the draws will be around. We're going to take the average of the box. 1, 2, 3, 4, 5, 6, 7, 8, 12 divided by 6 is 2. So the average of the box is 2. So we take 2 times 100, and our expected value is 200. But we would expect that number to be off 1 SE. How do we find 1 SE? We plug those numbers into my calculator. I do one variable stat, and I get SD equals, what did you get? 10? So 11? Let me check and see what I get. So clear 1, 1, 2, 2, 2, and 4. Okay, exit out, stat, one variable stat. So I ended up with an SD of 1. Did you write this number? Okay, so the SD is 1, and then the SE is 1 times the square root of the draws, so I get 10. So I would expect 200 if you played this game, and you would be off by about 10. 68% of the people would be off by 10. Okay. C, the chance that the sum will be bigger than 250. So I'm going to draw a standard curve. I have 200 in the middle. And then over here is 250. How far off is 250? 50, which in terms of the SE is 5. And I want the right tail. Well, do I need to use anything to figure out the percentage of the right tail if it's 5 SDs? It's going to be 0. Is it impossible?
Wait, can you say that again?
So we're 5 SEs to the right. Okay? So if we're 5 SEs to the right, how much area is in the right tail? None. Because, well, if we were doing shade norm, what would you type in for shade norm? From 5 to 5, right? 5 is the point where we quit caring. So you'd have to say 5 to 6 or 5 to 10, and there's nothing over there. If we played this game 1,000,000 times, is it possible to get 250? Yeah. What's the highest possibility? 400 is the maximum. So if we played 1,000,000 times, would we expect 250 to show up? Probably, but it would show up in such, it would be so rare, it's not worth looking at in percentage form. Once we get to 5 SEs, we quit caring. Right? That's the number we chose to use when we do shade norm, because that's the number that's so small, it gives such a small value, we don't care about it anymore. Okay. Number 2, 100 draws will be made at random with replacement from the box 1339. How large can the sum be? 900. How small? 100. How likely is the sum to be in the range 370 to 430? Well, what's the average of the box? 4, 7, 16. So 16 divided by 4 is 4. Okay. So the average is 4. We times that by 100 and we get 400. So our normal curve, we have 400 in the middle. And what is the SD of the box? Or sorry, yeah, the SD of the box is 3. So the SD of the box is 3. We multiply that by the square root of 100, and I get the SE is 30. Okay. So the expected value is 400, but 68% of the people will be plus or minus 30. Well, it just turns out that the question is asking me from 370 to 430. So it's 1 in either direction. So how much area is in here? 68%. We don't even need to do shade norm, or we don't even need to look at the table. We have that one memorized. Okay. Okay, you can draw either 10 times or 100 times at random with replacement from the box -1 and 1. How many times should you draw? A, to win $1 when the sum is 5 or more and nothing otherwise. So, are we more likely to have a sum of 5 or more with 10 draws or with 100 draws? So plus 5. Are we more likely to have a chance error of plus 5 in 10 draws or 100 draws? The chance error gets larger the more we draw, but the percent error gets smaller. Right? So if I get a plus 1 and a minus 1, what's my sum? 0. What's my chance error? 0. If I draw, let's say 6 times, I get 4 ones and 2 negative ones. What's my sum? 2. What's my chance error? 2, because it's 2 bigger than 0. Okay? So what A is asking is, if you want your chance error to be 5 or more, do you want to draw 10 times or 100 times? 100. Because the more draws, which is equivalent to the chance error, right? The expected value is 0, so whatever the sum is, that's our chance error. So for A, we want to draw 100 times because we want our chance error to be large. Okay? B, to win $1 when the sum is -5 or less and nothing otherwise. Also 100 because the chance error in that case would be, it's still 5. Okay? To win $1 when the sum is between -5 and 5 and nothing otherwise. Definitely 10. Why? We want a chance error between 5 and -5. And if we draw a million times, what's the chance that our chance error will be between 5 and -5? Very, very small. Yeah. So for C, we want to draw 10 times. All right, 4. 100 draws will be made at random with replacement from that box, and 25 draws will be made at random with replacement from that box. Which is better if the payoff is $1 when the sum is 550 or more and nothing otherwise? Okay. Do I need to calculate the expected values and the SE and all of that? You could, but somebody wrote in my book. Apparently the college sent me a used book. How about that? Okay. So, we're going to make 100 draws out of the first box and 25 draws out of the second box. What is the expected value of the first box? Is 500 with an SE of 30. Okay, and then on the next one, the expected value is Still 500, right? And the SE is 20. Why is this SE smaller than the original? Are the numbers any closer together? There's 11 in the bottom and 7 in the top. You guys aren't paying attention. Yeah, I'm talking to you. We had fewer draws. The numbers are bigger and we're drawing fewer times. So in the top, we're multiplying by 10. In the bottom, we're multiplying by 5. That's why. More draws. Okay. So which is better? If you win $1 when the sum is 550 or more and nothing otherwise, which one is more likely to give a sum bigger than 550? The top one. How come? The SE is larger. So in the SE is larger, which means we are more likely to get a score higher than 550. Right? Does that make sense? And if you don't understand, watch this. So they both max out at 500, or I mean, they both have an expected value of 500. We want 550. Well, that is a 50-point difference. What's the z-score? Well, for the top one, 50 divided by 30 is 1.66. And for the bottom one, 50 divided by 20 is going to be 2.5. Which one has more area to the right? The 1.66 will have more area to the right because 1.66 is closer to the middle. So if I were to do two separate curves, one of them would give me a z-score here at 2.5, and the other one is going to give me a z-score here of 1.6, and there's more blue area to the right than there is red area to the right. And I could have figured that out without calculating it because I know that this SE is bigger. So it's more likely to capture 550 than the other one is. Okay. B, $1 when the sum is 450 or less. It'd be the same thing. The z-scores would just be negative. Negative 1.66 has more area to the left than negative 2.5 does. Okay. When the sum is between 450 and 550. That would be the second one because plus or minus 2.5 is going to capture more central area than plus or minus 1.6. Does that make sense? All right. 5. Suppose that in 1 week at a certain casino there are 25,000 independent plays at roulette. On each play, the gambler stakes $1 on red. Is the chance that the casino will win more than $1,000 from these 25,000 plays closest to 2, 5, or 98? We already know the average of the box. What is it? It's 5.2 cents per play. Okay. So 5.2 cents per play. So if we make 25,000 plays, oh, hey, guess what, guys? 250,000 is equal to 250,000. Just in case you didn't know. Yeah, I'm serious. That is totally true. So, $1,300. So we have $1,300 here. And we want to find more than 1,000. So here's the 1,000 mark. Well, we need the SE. What is the SD on a roulette wheel? It's really close to 1. Because what's in the box? We have 18 ones and 20 negative ones. So how far are those away from 0? Really close to 1. It was like 0.998 or something like that. So we'll just say 1. Okay. I told you yesterday there's no shortcut for the SD of the box, and I found out that there is a short case in some cases. Most cases there isn't, but in some cases there is a shortcut, and we'll learn that later. So the SD of the box is really close to 1. It's close enough to 1, we'll just say 1. Okay, and what do I multiply that by to get the SE? The square root of 25,000, which is, so 25,000, is it 2,500 or 25,000? 1,000. And I'm going to raise that to the 0.5, and I end up with 158 times that by the SD of the box, which is 1. So we get 158 is our SE. Now what? We need a z-score with an error of negative 300. So negative 300 divided by the answer is 1.89, negative 1.89. Shade norm. Clear my draws. Shade norm. What do I type in? To 5. Because it was just larger than 1,000. So this percentage is going to be the chance that the casino wins more than $1,000 if 25,000 plays occur. So the casino has they have a 97% chance of winning $1,000. Now, do you want to know the crazy thing? That is if everybody bets $1. But what if people bet all sorts of amounts, and instead of looking at the number of the number of plays, we just look at the amount of money spent? And it's going to be a little bit smaller than that because the fewer times we play, the bigger the SE is. But it's not that far off. So basically, the casino, 97% of the time, they win $1,000 for every $25,000 that passes through the table. How do you win in Vegas? You become the house. The casinos don't gamble. The casinos have statistics on their side, which is why you shouldn't bet. But I love Las Vegas. The parking is free, the food is cheap, there's a lot to see, and people pay for all of that stuff, and I don't have to. So I love going to Vegas. It's great. All right. So the answer is 98. Suppose that one person stakes $25,000 on one play at red or black in roulette. Is the chance that the casino will win more than $1,000 for this play closest to 2, 50, or 98? We don't need to do any calculations here. So if you bet $25,000, what are the two possible outcomes? You lose or you win. Right? Now, is the chance of winning 50%? No. But it's close, and the question is asking, what's the chance you win $1,000 or more? Well, if you win 25,000. If you lose, you win 0. So it's 50%. Right? And that $1,000 is totally pointless. It could have been $1, it could have been $24,000, could have been $6, could have been 1 cent. The chance that you win more than that is about 50%. No, if you go to some of the older parts of Las Vegas, they do have penny slots still. Like if you've ever been to Fremont Street, that street that has the TV that's like 2 blocks long. Oh yeah, I haven't been there since they put the zip line. But some of those old casinos in the old downtown still have coins. You can still use real coins. You can play the penny slots. Yeah. No, don't do it. You're still likely to lose. They're all bad. Okay, but when you play, if you bet a penny, you only pick one line. If you bet 3 pennies, then any 3 lines. And if you bet like 10 pennies, then you get the 3 lines and the crosses. So you'll probably not end up betting a penny. You'll probably end up betting 10 or more. All right, where are we? Yeah, so when the slot comes up, there are 3 rows. And so a single bet just gives you the middle row, and then a triple bet will give you all 3 rows, and then like, I don't know, 6 or 9 times bet will give you all 3 rows and the X's. So, you might bet and you get, on the bottom row you get cherry, 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 but you only bet the middle row so you don't get paid. Yeah, so it's all bad. It's all a bad idea. Okay, where are we? 7. A gambler plays once at roulette, staking $1,000 on each number. Is that a good idea? So there are 38 numbers. We're going to bet $1,000 on every number. How many times will we win? 1. How many times will we lose? 37 times. So how much do you think they're going to pay you for winning? Less than 37. They're probably going to pay you 35 times. So what's going to happen? You're going to win once, and I think the payout is 30. I think when we did this with 17. What page was that on? Okay, so it's back on page. No, a split is 17. Okay. It's back on page 283, at the bottom of 283. If you bet on a single number, you win $35. So if you bet every single number, you're guaranteed to win, but you're only going to win $35. How much will you lose? 37, and this is in thousands. So you would bet 30, you would lose $37,000, and you would win $35,000, which means you lost $2,000, which is a bad idea. Okay. A box contains 10 tickets. Each ticket is marked with a whole number between -1 and 5. The numbers are not all the same. Their average equals 0. There are 2 choices. 100 draws are made from the box. You win $1 if the sum is between -15 and 15. And 200 draws are made from the box, and you win $1 if the sum is between -30 and 30. Okay, we don't know what's in the box, but we know their average is 0. So we're not sure what the SDs are. What this question is this question asking about chance error or percent error? So as we draw more times, we would expect chance error to go up, but we would expect percent error to go down, right? So we want to know 100 draws. We would expect it to be between -15 and 15. and then 200 draws between -30 and 30. Okay? Which one is a better option? It's got to be B. Okay, so with 100 draws, we would expect a chance error to be like X, and our percent error to be Y. Okay, watch this. Come on, Malone. If we draw 200 times, we would expect our chance error to be what? Our chance error is going to be bigger. Is it going to be twice as big? So let me do it this way. This expected value, whatever the expected value is, Z, in here, when we double the number of draws, our expected value will double, is 2Z, right? Now, this would be like x1. We know that x is smaller than x1, but is x1 equal to 2x's? No, it's the square root of 2, right? So if we double this side, then they're equal. So when we double the number of draws, our expected value doubles. Everybody understands that? But will our chance error double? No, it will get bigger. But how much bigger will it get? It's the square root of 2. So even though this one is larger than that one, it's not twice as big. Right? It's the square root of 2 times as big. So that means we want to choose B. Because the 15 was doubled to 30, but we don't expect it to double to 30. We expect it to be the square root of 2, which is 1.4. So the answer is B. Oh, hey, we got to go through, sorry. Choose one of the 4 options below, explain your answer. So A gives a bigger chance of winning. False. How would you explain that? Because B gives a better chance of winning. I don't know. Oh, choose one. I see. It's B. That's a dumb question. Yeah, so yeah, it confused me too. No, the answer is 2, which is B. Well,